Greetings everyone, we are Group SOFIE and we are here to present the design and specifications of our product. My name is Darren Ambat.
And I'm Marvey M. Castor.
I am Genesis Cruz.
I am Leanne Joshua Dela Cruz.
And I am Ribon Emmanuel.
Let's start off with the product model. Here we can see a rendered model of the SOFIE robot. At the very top is its head that houses a set of cameras and sensors to scan and collect information. This head is attached to a rotating neck capable of rotating 270 degrees in both X and Y axes. In the front of its body is the touchscreen controls used to operate the various functions of the robot. The graphical user interface for this will be shown later. Towards the sides of the unit are four mechanical arms capable of swiveling and extending in accordance with the task it is performing. Each arm has a special tool that can be used to perform various tasks. These attachments include a four-fingered claw gripper, primarily used for carrying and grabbing objects, a three-fingered claw gripper for picking up smaller objects or performing precise tasks, an adaptive robot hand for versatility, and an interchangeable vacuum arm for cleaning operations. The main body is attached to the wheel system through a metal shaft that also rotates up to 360 degrees horizontally. Lastly, the robot uses three pairs of small wheels for locomotion and is capable of accelerating, turning, and moving in reverse. Moving on.
Our design is based on popularity and simplicity, improving productivity and reducing costs in the long run. Design should be the simplest and least expensive while still meeting customers' expectations. For the visuals of our product, the front view, our product is an alternate version of an animated character Wall-E. As we can all see, our machine's main body has a backside figure made with aluminum steel, strong enough to withstand warpings, punctures, and deformations. The body's volume and area are big enough to hold the parts of the machine in order, involves meeting the requirements of the customer and the requirements needed to be documented. Next is next Next is the side view. The sides are more expansive than the machine's front view to hold multiple arms attached. This design is introduced so that the robot can fit into tight spaces without having any contact with surrounding obstructions. Next.
So the application of the robot, it is for medical and care services. It weighs about 40.8 kilogram, a volume of 0.021 cubic meter. Its height is about 1.5 meters, and the nominal payload capacity is about 4.5 kilograms, and its duration is approximately about 6 hours, and max speed at 0.3 meters per second. So the graphical user interface, it can be seen in the front of the robot. There are 6 buttons, which is the navigation. It is programmed to have path planning, and obstacle avoidance using the camera. Vision to detect any object, human, and fire type that encounters. Audition, speech recognition, and speech synthesis. The gripping is for adjusting the pressure of the grip. Cleaning, as it indicated, and the manipulation for its control and kinematics of the robot. And there is a time, weather, and date indicated. There is also an emergency button on the lower right to send distress signal on the site where the emergency is occurring. Next.
So we have here the main components. The control system. A robot's control system uses feedback just as the human brain does. Sensors. Robots receive feedback from sensors that mimic human senses. Actuators. Actuators mimic the action of human muscle to move parts of the robot's body. Power supply. To make the robot function, obviously it must have a power. End effectors. Robots are equipped with tools called end effectors to interact with the environment and carry out assigned tasks. Functionalities. Task planning. The robot should know how to rank the tasks according to importance. Next is path planning. The task requires the robot to grasp and manipulate objects, and grasping cannot be achieved with purely haptic feedback. Next is grasp planning. The task requires the robot to grasp and manipulate objects. Next is visual object recognition. The task requires the robot to fetch a particular object. We have here visual person recognition and identification. This task requires the robot to interact with people. Next is simultaneous localization and mapping. The task requires the robot to move in the environment. Next is speech understanding. This task involves taking commands or similar information from a human user. Lastly, we have speech generation or speech production. The robot must communicate with a human user by voice or otherwise produce auditory feedback.
Then, as for the heterogeneous robot control perspective in charge of the robot's task execution, so here are the set of skills, hardware resources, and software resources. Some features are navigation, vision, addition, gripping, cleaning, and manipulation. And some of the hardware resources are the mobile base, laser scanner, sonar rangers, and depth sensing camera. And for the software resources are the localization, map handling, path planning, and obstacle avoidance. As we can observe, these set of skills are in our graphical user interface so that they can choose which skill they want the robot to execute. Then for the heterogeneity of tasks of our robot, so here are some of the skills that they can do, which are fall detection, door opening, food delivery, medication reminder, cleaning, and surveillance. So as we can see, these are some of the basic tasks that are used for emergency situations. So that's all for our design and specifications of our SOFIE. So thank you for listening.